Hello everybody and welcome back to another visual pattern challenge. We've got a crazy one today. Here's step 1, here's step 2, here's step 3, and your challenge is to determine how many of these little hatching chicks are going to be in step 4. If you can do that, can you predict how many in step 43? And can you write an equation that could be used to express the number in any step at all? Let me tell you, the numbers here get big really quickly. If you'd like to accept that challenge, pause the video and see what you can do. All right, so, I guess, the first thing I would ask is, what do you see here? And does that give you any clues about what kind of a pattern this is? And I guess what stands out to me are these big squares, right? And they're getting big pretty quickly. This one is 4 by 4, and this one is, how many is that? 3, 6, 9 by 9. And then we've got a little left over. Oh, and I guess if we follow this pattern, this is a 1 by 1 square. So since I'm seeing squares growing, I'm guessing it's quadratic, although I'm not sure. Something to do with that, though. And now the leftover pieces, that looks pretty easy, so I'm going to save that for the end. It just looks like the step number. We've got 1 and 2 and 3. So I'll tack that on the end. The trick is determining how to get the square, the size of the square. So let's think about this. It's 1 by 1 here. It's 4 by 4 here. And it's, oh man, 9 by 9 here. So I've got in step 1, 1, in step 2, 4, and in step 3, 9. What jumps out at me is that those are the squares of the step number, right? 1 squared is 1, 2 squared is 4, 3 squared is 9. So to get one side of the square, we're going to take the step number and square it. And then to get the whole square, we actually have to square that. So in step 3, I'd put in 3, I'd square it, that gives me this side, and then square it again, and I get all of these, whatever it is, 81 chicks. And then I've got this stuff left over, that's just the step number, 1, 2, 3, so that's plus x. So in step 4, we're going to take the step number and square it to get the side length. So that's going to, this big square is going to be 16 by 16. And plus, we'll have the step number, so we'll have plus 4 at the end. So 16 by 16 and plus 256, I think, is 16 squared. And plus 4, that's 260. So I'm predicting 260 for step 4. What do you think about that? All right, so this reasoning has led us to an equation, and I am not going to try to analyze the numbers in a chart. If we simplify this, when you take something, a power to a power, you multiply the power. So this is x to the 2 times 2 power. So this is x to the 4th plus x. And these numbers get big so fast, if we try to take the differences and see anything useful in there, it's going to take us a long time to do that. And we'd have to figure out a lot of step numbers to make that make sense. So I think because this, well, actually, let's just double check that it does work with all of these, right? So in this one, we would have 1 to the 4th plus 1. Well, 1 to the 4th is just 1, and there's the other 1. So that's 2. That's how many chicks we have. Here we'd have 2 to the 4th plus 2. So 2 to the 4th, that's 2 times 2 times 2 times 2. That's 16. Plus 2 more is 18. And yeah, that's how many we have there. And here we would have 3 to the 4th. 3 to the 4th is 81. 3 to the 2nd is 9. 9 times 9 is 81. And that's how many we have right here, plus the 3 left over for the x. Yeah, so this equation does make sense. So I think I can trust it. So I'm going to write this down as y equals x to the 4th plus x. And now to calculate step 43, you just have to take 43 to the 4th power, which is not going to be a small number, and then add 43 to that. So this is 43 to the 4th power plus 43. And let's see, on my calculator, I'm getting 3 million, I'm just going to add the whole thing together, 418,844. Go ahead and double check that for me, see if that's what you get, and let me know. But that is a big number. I think this is the first time we've had a 4th power in one of these patterns. So, a second power is called a quadratic. A third power would be a cubic. So this is a quartic equation or quartic pattern because it's got a fourth power as its highest term. How did that go for you? Did you get 260 in the next step? I think that was pretty difficult. Did you get an equation like this, or did yours look different? I'd love to know. Thanks, everybody.